let's get back to our motivating example about the landlord with the 50 water heaters. So the question was, what is the probability that at least 16 of those 50 water heaters would last at least 10 years? So we already answered the questions about N being 50, P was 0.25, and Q was 0.75. So new is to think about what mu and sigma are. So mu, the expected value of a binomial distribution, or the mean, is N times P. So 50 times 0.25, or if you'd like to think of it as 50 times a quarter, or 50 divided by 4, however you'd like to look at that. So this is 12.5. Now what about sigma, the standard deviation of the probability distribution? Sigma is the square root of N times P times Q. So square root of 50 times a quarter times 3/4, that's 70.75. So you can, of course, just use your calculator to do 50 times 0.25 times 0.75. So let's see, 150 over 16. And so you can use your calculator, or use your calculator to do 50 times 0.25 times 0.75. And take the square root of that product. Okay, so that product turns out to be 3.067. Now we also wanted to know what NP and NQ were. So we've given them here, so remember again that this is just the mean, and NQ would be 50 times 0.75. So just note that these two, NP plus NQ, what do they add up to? They add up to 50 in this case. These will always add up to N. So if you've already found one of these, you can find the other just by N minus it. They add up to 50. So if you've already found 12.5, you could have done 50 minus 12.5 to get the other one, 37.5. And let's see why, because if I factored out the N, I'd have P plus Q. But remember, P plus Q is 1. Those are probabilities of complementary events. So N times 1 is N. In any case, we found NP is 12.5, NQ is 37.5. So the question is, why can we approximate the binomial distribution with a normal distribution? Because both of those products, NP and NQ, are bigger than 5. Okay, so this technique is going to be applicable in this situation. So how do we figure out what this probability is? We're going to use the continuity correction on our discrete variable r, and we're going to use the mean and the standard deviation of the original binomial distribution, which are given here, the mean and the standard deviation of the original binomial distribution. So what is the question? R is a discrete random variable. So what are we looking for? We're looking for R is greater than or equal to 16. So now we've gone from R as discrete, now we want to make it a continuous variable. So we know we have to make, this is where the continuity correction comes in, is this step right here, going from R to X, going from a discrete random variable to a normal continuous one. So we know we're going to either add or subtract a half. Which is it? So if it's bigger than or equal to, we're going to subtract a half. So we're going to end up with 15.5 here for our X variable. And now Z. Now we're going from one normal to the standard normal variable. So Z, as before, is X minus mu divided by sigma. We are using mu and sigma from our binomial distribution. Here they are, mu and sigma. So when we plugged in 15.5 for x and this mu and sigma, we have 0.9798. So our z-table only uses 2 decimal values, we're reminded here, so let's go back and we'll change that to 98. Great. So now we would use our z-table to find the actual probability. So notice here, this is looking for an area to the right. So we have 2 options. You can do 1 minus the value on the table. You looked up this value on the table. Or you could look up the probability that z is less than or equal to negative 0.98 and end up with the same probability. Either way is fine, your choice. Oops. So there we have it. We have completed this example, and we started with a discrete random variable r. Because we knew NP and NQ were greater than 5, we could change r to a continuous variable. This was our continuity correction right here, our continuity correction. And then we're back to our situation from the very first sections of Chapter 7, going from one normal variable x to the standard normal variable z. So a couple of things to keep in mind is we need NP greater than 5. This is the same as mu being greater than 5. And we need NQ greater than 5. Then we can assume then R can be approximated by a normal distribution, which we'll use x for, and mu and sigma will be from our binomial. So mu will be NP and sigma will be the square root of NPQ. The continuity correction from R to X, if R is greater than some number, let's say R is greater than a value V, then X will be greater than or equal to V minus a half. And if R is less than or equal to V, then X will be less than or equal to V plus a half. So now take a look at Blackboard, and you have a video watching check to see if you got the crucial points, and then you'll be ready for doing the homework.